Hello everybody, getting ready to do lesson 4.5 of Geometry 1 Math. It will be part 1, part 2, part 3, email. 4.5, the converse of the Pythagorean theorem. We have a classwork sheet of 34 points, and we have a 0-point notebook responsibility. Here is your standard for this lesson. Teachers, here's the bell work. Have your students do this in about 5 minutes for this, 4 minutes for this. Okay, welcome back everybody. 1/3 would be your fraction for this. Then down here, solving the inequality, x would be less than 3 for this inequality here. Okay, theorem 4.8, the converse of the Pythagorean theorem. Words, if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. That is a pretty good definition there of a right triangle. Then here are the symbols here. ABC is a right triangle. Here's our hypotenuse, A and then B here. Example 1, verify a right triangle. Is ABC a right triangle? So how do we know? Is that a right triangle? Let C represent the length of the longest. Check to see whether the side lengths satisfy this formula here. And will it satisfy that? Compare C squared with A squared plus B squared. So to do that, we need to plug in values here. 20 squared, does that equal 12 squared plus 16 squared? Does that equal that? And it looks like it does. So therefore, yes, ABC is a right triangle by plugging in our values there and proving it. Okay, I got to practice show that the triangle is a right triangle. We're going to show that's a right, or try to. Students, this is you. Start work on this now to see if it is a right triangle. Okay, welcome back. Here's our work for this triangle here. It is a right triangle. We plug in our values here. 26 squared, does that equal 10 squared plus 24 squared? And then down here is 25 squared equal to 20 squared plus 15 squared. Triangle is right. Both right triangles, classifying triangles. In triangle ABC with longest side C here. If C squared is less than A squared plus B squared, then triangle ABC is acute. If C squared equals A squared plus B squared, it is right. And if C squared is greater than A squared plus B squared, then ABC is an obtuse. So these are good definitions here of triangles by doing side length. Example 2, acute triangles. So the triangle is an acute triangle. So what are we going to do? Compare the side lengths. We have C squared equals A squared plus B squared. Compare C squared with A squared plus B squared. And we plug in here. We get 35. How does that relate to 16 plus 20? In this situation here, it's less than. So it means that this triangle is an acute triangle. Technically, this would be an acute triangle because of these side measurements. Okay, so I got to practice classify a triangle. Students, this is yours down here, classified as triangle. Teachers, give your students about 5 minutes to do this. Okay, welcome back. It is obtuse because 36 is greater than the squares of the other two sides. In this situation here, 49 is less than 98, so this triangle here would be an acute triangle. That's how you would confirm that. And that's part 1 of lesson 4.5. Part 2, part 3 is available at the email.